So with that, it's 4 p.m. and I think I'm ready to go. Thank you very much for having me. It's a pleasure to present here at the Microsoft 365 Virtual Marathon. My name is Rainer Stropek and I'm broadcasting. Hometown is a small town near a town called Linz. It is in Upper Austria, right in the middle between Vienna and Salzburg. And I'm standing here in my house, and I'm looking forward to nearly an hour full of code, and the topic is Azure Durable Functions. I have been working with Azure for quite a while, for over 10 years. I started working with Azure when it came out in the first technical previews, and in the last 10 years, I have been doing a lot of projects with Azure. In my own company, we have been building software as a service solutions on Azure. We were helping customers to transfer to move into the cloud, to translate their business from an on-prem software business to cloud business. And recently, things like serverless functions, serverless programming, event-driven computing became super important for our business and our solutions. And the platform that you want to use in Azure for that is Azure Functions. And there is a specific flavor of Azure Functions, which is called Azure Durable Functions. And I would like today to focus on that. You will see only a few slides. I think I have 3 slides or something like this, and the rest will all be code. We'll stay quite a lot of time in Visual Studio and building a sample from scratch where I show you various aspects of durable functions, and I will also show you how durable functions do the magic that they are able to do. If you want to stay in touch with me, the easiest thing is to go to this URL that you can see here. It's a personal CV if you want, and here on the right lower corner you can see all the different social media links, including my YouTube link. I have a YouTube channel where I record all my sessions and presentations and so on. Take a look at it. You can get it for free, all my videos, all my presentations there. And of course, I also record this presentation, so you will be able to find it after my presentation, maybe tomorrow, something like this. Because it will be demo, you might be interested in the demo code. The only link that you have to remember is this one, bit.ly M365 durable funcs, and then that will lead you to the presentation that you currently see. And from here, you find the link to the GitHub repository with all the snippets, all the code samples, and things like that. And of course, my YouTube channel if you want to take a look at the recording, if you want to play the video and try the demos on your own side by side. And with that, that's all I wanted to show you, and I will put my video somewhere up here and tell you a little bit about the scenario that I'm going to show you in the course of the next an hour or so. The idea is that we are going to build a solution for traffic monitoring. We will have some fictitious traffic monitoring cameras set up, for instance, at a highway, and we have some Azure functions running here in Azure. In this presentation, I will not really going to use Azure. I will program everything locally on my computer because that is more stable while doing a presentation, but the entire code that you see here obviously runs in Azure too. Imagine that we have a really fast car going across the highway and our cameras recognize a speed violation. In our scenario, these cameras are smart IoT devices, and they recognize the speed violation and send the picture via an HTTP post to a function running in Azure. This function will trigger a license plate recognition component, could be maybe a trained machine learning model, and there are also free services on the internet that do quite a good job in license plate recognition. If they recognize the license plate with a high confidence level, then they will store the license plate and the speed violation in a database. That's fine. That's the boring stuff. We could do that with any kind of Azure function. That's not the topic of my talk today. I would like to focus today on a more specific scenario. What if the license plate recognition wasn't that good? The confidence level wasn't good enough. We still need some humans sitting, for instance, in a control center, and we need to ask them, hey, is this license plate read okay? So we need to ask an operator. And for the sake of this demo, I decided to simulate platforms like Slack or Teams or something like this. So I'm going to use a kind of webhook-based communication. So we will send a webhook towards Slack or Teams to display a message to an operator, asking the operator, hey, is that reading okay? And if the operator says okay, then Slack or Teams will send us back a webhook and we can store the reading in the database. Now, the problem here is why we need durable functions is that this process down here can take a while. As you might know, there is a pretty strict timeout for normal Azure functions. They are allowed to take milliseconds, maybe some seconds, but they shouldn't take minutes, hours, or even days. With durable functions, that's completely different. With durable functions, you can write functions that run for seconds, minutes, hours, days, forever if you want. And these durable functions even survive if Azure Functions is completely scaling down your solution to 0, scaling up and things like that. These durable functions, they care for automatically storing the state of your Azure function somewhere in Azure Storage. We'll take a look at that. And once the response comes back, once an event happens, for instance, a timer times out or somebody sends you a webhook request, then your durable function will be rehydrated. It will come up into memory and you can handle the requests accordingly. And this is exactly what we are going to build. And with that, let's get started and let's go into Visual Studio to start with developing this sample app. I'm going to create a new project from scratch here. And here we are going to create an Azure function, as you can see it here. This is the latest preview of Visual Studio 2019. So let's go here. Maybe I have prepared a folder. Let me see here, durable life. That looks good. And let's call it durable functions. That's good. Now, for this demo, I'm fine with an HTTP trigger, but of course, you could also trigger your durable function with any other mechanism of Azure Function. Please don't be angry with me if I don't go into details about generic things, about Azure Functions in general and what it's able to do. This talk is specifically about durable functions, and therefore I assume that you have at least basic knowledge about Azure Functions. If you don't worry, you will be able to follow my demo, but maybe you will look up some fundamentals, some basics about Azure Functions afterwards and re-watch my presentation, for instance, using the YouTube video. As you can see, I decided to go for .NET Core, latest version of .NET. We are not going to talk about authentication here, and I'm using the local storage emulator just to be sure, just to reduce the amount of internet traffic that I'm generating here. Of course, you can use your Azure storage in the cloud too. So Visual Studio is creating the project, as you can see here, and we have now our function. You see, this is the function. Let's put the video here so you can see the code, and I hope the code quality is somewhat okay. As you probably are aware of, you will see here my function one. Maybe let's rename this. This is a speed violation function, just to make sure that it is a meaningful name here. Speed violation function. That looks good, but I will not go for this one here. I will delete this function, and I have prepared a code snippet. Let's add a code snippet here, and the first code snippet is this basic function code snippet. The second thing that I'm going to need is some data transfer objects, which are not really interesting, but I have to add them. So please bear with me when I add a new class. Let's call it data transfer objects, DTOs, and we'll not need a class here. And let's add just a bunch of DTOs. These DTOs are just classes, just data classes with a bunch of property, nothing special here. It's not relevant for this presentation, so I will immediately close it and stick with the Azure function that you see here. Okay, so this is the basic structure of my Azure function. As you can see, it is triggered by an HTTP request. This is exactly the HTTP request that comes in when our intelligent IoT traffic camera recognizes a speed violation. We get red squigglies here because here we have something which is pretty interesting. We get an iDurable orchestration client, a durable client attribute here. With this attribute and this interface, we get from Azure Functions a possibility to launch a durable orchestration. That is an Azure function that runs for a long time using exactly that interface by using dependency injection. So for that, we will need some kind of usings. Let's take a look what Visual Studio suggests. And Visual Studio happens to suggest the correct NuGet package. It says, hey, Rainer, if you want to work not only with Azure Functions, but with durable functions, you need to install this package. Let's do that. It will fetch the package from NuGet and the red squigglies should disappear. Currently, we aren't doing something with this durable client. Give me another few minutes. You will see in a few minutes how we will use this starter variable, the starter parameter, to trigger a long running process from our short running process. Our function should return nearly immediately to the caller. And in the background, a long running function will do the heavy lifting for us. The last thing that I have to do is I have to remove Newtonsoft.json because in my code, I'm no longer using Newtonsoft.json. I'm using the new system text.json serializer because it's slightly more performant. It doesn't make any difference here, but hey, if we have it, why shouldn't we use it? If you take a look at this function now, it is really trivial. It takes the speed violation data transfer object coming in. This might be, for instance, the speed that was recognized and when was the picture taken and things like that. And then we just log an error, and at the end, we return just an HTTP 200 status code. Just to make sure that I didn't do anything wrong, let's quickly run the debugger here. And if everything is fine, the Azure Function toolset should come up. And in a second, it should tell us that, yes, we are listening on this URL here. So let's give it a try. Let's go here and let's send a speed violation recognition with this data to our function. And we run and, oh, we don't see, we have a 404 here. I obviously missed something. What did I miss? What did I miss here? Public traffic, host JSON, local settings, everything looks good. Version 2. What did I do? What did I do? Let me quickly check. I tried that many times. No jobs found. Okay. Let's quickly it shouldn't work like that. Okay, let's quickly start from scratch. I did something. I ruined something. Oh my God, but that's not a problem. That's a live demo, and in a live demo, things happen. So this will be now my durable functions second try. I am sure this stuff works. So HTTP trigger storage emulator, anonymous, that looks good. And this time, I'm not going to change anything here. Yes, of course. I think I know what I did. I messed up with the namings here. This time we should see a function coming up, and here it is. Okay, that looks very good. So now I can replace the function here. I'm not good in talking and typing at the same time, so sometimes these things we are. I think before I nested classes inside of each other. I think this is what I did wrong. So, okay, this time it looks really good. The only thing, again, that I have to do is I have to add my durable functions, my data transfer objects. Okay, here it is, data transfer objects. And now we are back into the game. Let's add the NuGet package. I did that before. And last but not least, let's remove Newtonsoft JSON. Okay. Good. Hopefully it will now work. And that looks pretty good. If we now go here and send the request again, we will get a 200, and I can show you everything works smoothly. If I set a breakpoint here we are, and send the request, you see we hit the breakpoint, everything is fine. Yes, now we are up and running and we can start coding with the durable functions. Okay. The first thing that we are going to do is we have here nothing implemented yet. Let's add a little bit of code now, and I can show you how we are going to work here. So let's add a function here. This function, store speed violation, implements a very simple functionality. It just simulates storing the speed violation in any kind of Azure database. Could be writing it to Cosmos DB, could be writing it to Azure SQL DB. In my case, I'm just simulating it by printing some log information on the screen. And here you can see the business logic that I implemented inside of my Azure function. I check the recognition accuracy that I was sent from the camera. And if it's okay, then we are immediately storing the speed violation. And if it's not okay, this is the point where we need to trigger the durable function. So this is the area where we have to add some code. Last but not least, in order to see what's going on behind the scenes, we have to reconfigure our logging a little bit. So let's go into my host JSON stuff here, and let's add a log level default information so that we will see our information output. Good. So far, so good. Now we can start with implementing our durable functions. So let's add a new file in which we will add our durable function. I will call it manually approve recognition, because this durable function will communicate with Slack in my case, or if I will simulate communication with Slack to manually approve a recognition by a human being. This is what I want to do. And then here in this class, let's add the basic orchestration function. And of course, I will walk you through this code. Let me quickly add the necessary usings so that we get rid of these red squigglies. And that looks pretty good. And just make it public so everything looks out nicely. So let's call this class manually approve, because I cannot give it the same name as the function. So let's take a look at this function here. Maybe put this one here because the resolution is not that good, so I will need a little bit of space. This is a durable function, and this durable function, the big difference here is that we get here the trigger using an orchestration trigger. This orchestration trigger signalizes that this is an orchestration function. That means it can run for quite a long time. Let me add the namespace here for the logger in order to be able to see the logs. And if we take a look at the code, the first thing that we do is we get the input of the orchestration function using the context. This is exactly this orchestration trigger. This is the data that we get from the function which triggers the durable function. Now we have some basic data about the speed violation. We haven't implemented the communication with Slack yet, so we will have to add some code here in a bunch of minutes. But I've added some already interesting demonstration code, because what you can see here is I'm setting up a timer, because at the end of the day, we want to have a timeout. If our human administrator does not answer within 60 minutes, or just because I don't want to wait 60 minutes to this, in this presentation, I added 10 seconds. If the operator doesn't answer within this amount of time that I specified here, I want to cancel the request and maybe maybe write some error to some log or whatever I want to do. And the important thing here is that I'm not using any kind of regular .NET timer. I'm talking to the durable function API. You can see it here. And when I want to get the current date and time, I also don't just say datetime.now, just like here, which I just do for logging, and we'll talk about that in a second, but I'm calling again the durable function API. Why this is important, I will tell you in a minute. Last but not least, I'm awaiting here the timeout task. Await just the same programming model as you would do for any other kind of timer. And we clean up the timer if it hasn't been cleaned up yet, and we just return. That's all. So in the current implementation, we should just see this program waiting for approximately 10 seconds and then completing. Okay, we will do some debugging here just to make sure that we fully understand how durable functions work behind the scene. Let me check. We didn't actually trigger the durable function from our regular function. Let's do that here. So we will add the trigger orchestration here. And as you can see, we are using here the starter object that we got here as a durable client inside our regular function here. So we need to start the manually approve recognition. This one, manually approve recognition stuff here, and the manually approve recognition stuff is here. So we will say this one, because I put it in a separate file here. So with that, we are starting a new durable function, and we can get rid of that one and return the default status object. What the status object is, you will see that in a second. Please note that I am using here the name of function. We could also write any kind of arbitrary function name here, but I personally don't like using magic strings here. I would really like to use strong types here. So I'm using C#'s name of feature, and here I'm also using C#'s name of feature, as you can see it here. So let's give it a try. And you know what? I just made up my mind. I will move this function here because the screen resolution is so poor here. I will move this function into the same file here just to make sure that you really have a good overview about what I'm doing here. So normally I do not put multiple classes or large functions in a single file, but in this case, it really makes sense to put it into one and the same file. Okay, so now hopefully we get a better overview, because now we can see, if we check it out here, this up here is the durable function. This is the classical function. The classical function uses the durable client to trigger the manually approve recognition orchestration function. And this orchestration function is using the durable functions SDK to do things like get current time, waiting, timeouts, and things like that, and many other things more that you will see in a second. So let's run this code. Let's run this code and take a look at the output. I will start the debugger. Maybe I should fix. Oh, yes. Maybe I should fix the error here. It's done, and start the debugger. Good. Comes up here. Nice. Good. Let's keep that running, and let's go here on the right-hand side with my Visual Studio Code. I have to zoom out a little bit in order to get a little bit of more screen estate. Now let's send another request, and in this case you see the recognition accuracy is pretty bad, so it should trigger the durable function. Let's try that. Let's run it and let's see what's going to happen. As you can see, we entered the manually approved recognition, but I'm not touching the keyboard now, and we are going to wait and see what's going to happen. Because I told you we are waiting for approximately 10 seconds, and this is exactly what I wanted to show you. The timeout that I implemented in my C# durable function, it was triggered. But the interesting thing, the thing where I would like to point your attention to, is this output, entering manually approved recognition at 1642, and here again entering manually approved recognition at 1624.57. We see that the durable function is called twice. And this is the magic of the durable function API. What's happening behind the scenes, let me stop the debugger to get a little bit more screen estate here. What's happening behind the scenes with the durable function is that the SDK will restart your durable function over and over and over again. It is durable because it stores its state in Azure storage, and it starts always from the beginning. And the magic here is that whenever you do an operation like getting the current date and time, it will not return the current date and time when the new function runs again and again and again, but it will return the first time you execute the function, the current date and time, and afterwards it will give you the same result of the get current date and time function that you called previously when running the function for the first time. Therefore, it's possible to always start the durable function from the beginning over and over again. And C# can be sure that only those operations are executed which haven't been reached before. So in our case, after 10 seconds, the entire application runs from scratch. It will jump over all the things which were already executed previously, and only the new code, in our case, the code which is here after the await, is executed afterwards. If you want to take a look how this is managed, you can take a look at Azure Storage. This is my Azure table storage. You see it here, and you see a bunch of tables here, which are called test hub name history, test hub name instance. If I click here and refresh, for instance, you will see that I have a bunch of entries here, and you will also see that my whole data is stored here. What we also see, if we take a closer look at what the user who triggered the function got returned, is the user got returned an ID. And whenever you want to continue with the function, because for instance you are sending in an interesting event, you have to specify this ID again. You can also use the URL that you get from durable functions to query what is the status of a certain process, of a certain orchestration, of a certain durable function. For instance, if I use this status query get URI, I do that here. Let me do that. Oh, I stopped the debugger. I'm sorry. So let me show you that, because that is important. Now you know more about what's going on behind the scenes, so we can run it again. Let me show it to you here. First, we are using our regular function. This time, we got an ID 7619F84 and so on. And now with this status URL, this one, we can ask, what's the status of this process? And it says it's currently running. And if I do that multiple times, now you see, it's completed, because now the 10 seconds are over and the durable function is done. So the idea, what you should take away from this demo, is that for a durable function, the code always runs from the beginning. And by storing the state, essentially storing your local variables in Azure storage, and by adding a little bit of magic behind these context methods, the function runtime can make sure that everything is run only once, and a safe replay mechanism has been put into place. Okay, so this is the first idea that we have here. So I think we can start making our application a little bit more interesting. Let me quickly take a look at what we will do now. Yes, we will. Next one. Go here, send the request to Slack. Here, this one, and replace that with a little bit of business logic. First, add a helper function. Let's add a helper function here. This one. Here, send approval request via Slack. I'm not sure if you have ever done some work with some instant messaging tools like Slack or Teams or so on, but essentially if you want to talk to a specific user, if you want to display a message there, you essentially send an HTTP request. And this function is a placeholder for that. Imagine here is some complex code where we talk to the Slack API or the Teams API displaying a certain message. I'm just simulating that here, printing out a log information. But essentially, we are talking to Slack, telling Slack, hey, display a message on the screen of the operator. The important thing here is that this is a so-called activity. So in an orchestration function, you always call activities, and that's important. You have to use the durable function API to trigger an activity, because when the durable function runs again from the beginning, the API will recognize that you have called the activity before and jump over the call when it reruns the entire message. The whole result stuff and so on is automatically stored inside of Azure Storage. So let's trigger send approval request via Slack by doing that here. I have a code snippet for that. Trigger approval request. This is how you trigger an activity. You call the context method and you have to await this stuff. This activity can take quite a long time, or in this case, it will not take a long time because it's just the HTTP, but the process that it triggers can take quite a long time. In our case, we are sending an HTTP request to Slack and storing the result of this HTTP request in Azure Storage. So the next time, this thing will just jump over this call because we already did the call to the activity. This is the name of the activity, and as you can see it here, I'm also pasting in, I'm also passing on some payload that this method down here can access. You see, this is the DTO, the data transfer object that we pass into the activity. It's pretty simple to implement an activity because it's just a function, nothing more. Okay, so this is good. We now called the activity. We sent the request to Slack. The next thing that we have to do is we have to turn storing of our speed violation also into an activity. And now we already learned how to turn a regular function, which just stores some data in Azure, into an activity. I have prepared a snippet for that. The only thing that we have to do, compare these two implementations, we have to add the activity trigger attribute here, and we have to add a function name attribute on top. That is all we have to do. So turning a function into an activity is really not difficult. And now that it is an activity, we can use it into a durable function and in a regular function. Here you can see the call inside the regular function, which is not long running. And now we will add the same call to the same function, but in a durable way. So we'll go up here, look for the correct place. It will be this one. And add exactly this one. Here you see it. Call activity async, store speed violation. This is the call to our activity. We will need some external event that we can wait for. Let me quickly add this one because it's nothing else than just a string constant. It's really simple, and I will describe in a second what's going on here. This is the event name. This event here we are waiting for an external event. And now let's take a look at this code to fully understand what's going on here. This one we already know. I set up a timer, and in my case, the timeout is 10 seconds. So within 10 seconds, the user must click on approve or decline. Of course, in reality, it would be more like 60 minutes or so. But then here, we are waiting for an external event. So somebody can take the ID of our durable function, send us a request including the ID of this durable function, and then our durable function will continue to run. And this can take minutes, hours, days, or weeks if you want. The workflow will stay inside of Azure Storage and it will rehydrate as soon as we get this external event. You will see in a second how we trigger this external event. And the beautiful thing here is that I can use the C# task parallel library function to do a regular task when any, where I wait either on the timeout or on the approval response, depending whichever comes first. If the approval response came first, we can store the speed violation because that is exactly what we want to have. Last but not least, let's change the return statement here a little bit to indicate the winner. The winner, if this is the approval response, and the approval response result is something, then we will return true. Otherwise, we will return false. It's not that important here. Last thing that we need is we need a regular function to trigger the external event and continue our durable event. So we always have regular functions in place which communicate in the background with our durable function. Let me show you what I mean here. So let's add the process Slack approval. This process Slack approval is a pretty simple Azure function, a regular Azure function, nothing special here. You see, it's triggered by the HTTP trigger. It again has this API, the orchestration client, but the important line of code here is this one. We are not starting a new orchestration, but we take the orchestration ID that was passed back by Slack. In our case, Slack could get some state data when we ask it, like a bot display something on the screen. It can send back the state data when it sends back the answer of the user. So what we take here, we take the input, the orchestration ID, and we fetch a reference to the already running orchestration. And then we can, you can see it here, raise an event. This raise event async will now look for the correct durable function and will make sure that the function will continue from here conceptually. You are now no longer thinking that it runs from here. You already know that it again runs from the very top. But all these other things like the create timer, get current date, and so on is not really executed, but the previously returned values are fetched from Azure Storage, and conceptually the method starts its work from here. Okay, and if everything is okay, we store the speed violation. Let me show you how that looks like. Let's run the debugger. Here is the debugger. Good. Let's go here and let's start a new workflow. This one, start it. Let's check it. It's currently running, and just to be sure we are fast, you see, this one is now the method that I call the process Slack approval. We are simulating the webhook from Slack into our Azure function, and we pass in the orchestration ID, you see it here, that we got from this query up here, this one, speed violation recognition. We take the body and read the ID and pass it on here. So this is a kind of glue between the different calls to regular Azure functions, because in the backend, they need to find the running durable function to communicate with it and rerun the correct function, or no, not rerun, that's the wrong word, conceptually continue the durable function at the correct point in time. So this is how you work with external events. And if we take a look at the output, you will see that at the end, let me quickly take a look where I can see it somewhere here. Yeah, you see the calls to the manually approve recognition, and this is the line that I was looking for. This is the line that I print out when finally the speed violation has been stored to the underlying database. That's just a fictitious call, but I think you get the idea. If I wouldn't have been so fast to react within the timeout, the speed violation would not have been stored, and I would have to change my business logic to store it maybe on a different place where an administrator takes a closer look why the operator hasn't answered within the specified amount of time. Okay, that looks good. If we try that again with the debugger, I can also show you how this orchestration, this durable function, enters again and again and again at the beginning. Let me set a breakpoint here. I'm now in the debugger, and if I do it again here, click Start a new workflow. Now we are starting the workflow, and within 10 seconds, I have to write it again. Within 10 seconds, I need to post this one, and you see we are starting the manual approve recognition function again from the very beginning. This is the mechanism that I wanted to show you and that I've shown you before. Maybe those of you who closely follow the code, maybe you see that you get a warning here. DateTime now violates the orchestrated deterministic code constraint. That means that you get a warning here because you shouldn't use datetime.now. I consciously violated this rule here because I wanted to demonstrate that this method is called over and over again. In real life, instead, we have to use this function here. See that one? Because this function plays nicely with the fact that we are starting our durable functions over and over again, and it will return the correct date and time in a second, third, and nth run of our function that we got during the first run of this line of code. This is durable functions as they exist for quite a while now. And recently, Microsoft has added another feature, and this is called durable entities. And I would like to spend the last 7 minutes or so talking a little bit about these durable entities. Durable entities are similar to durable functions, but the programming model is a little bit different. Durable functions, you saw it before, are an orchestrator kind of workflow where you can send messages into this workflow, and this workflow can pause and wait for certain messages, exactly as we have done it before. But imagine the following situation. In our situation, for instance, the workflow could start a lawsuit. Somebody was way too fast, and so we have a lawsuit. And this lawsuit is a dedicated entity. It has an ID and it has a lifetime. And the programming model of durable entity is that this becomes a kind of data record in a database, but we don't have to explicitly store the data record ourselves. We can just say this is a durable entity and let Azure Function manage the lifetime of this entity. And then we can again use regular functions like this one to interact with the durable entity in the background and store write data to this entity. And whenever we need, we can use the ID of the durable entity, in our case, the lawsuit ID, and ask for the current status. Did we already find out who was the driver of the vehicle? Did the judge already set a fine for the speed violation? Did the speed violator already pay the fine, for instance? This is how you work with durable entities. And let me quickly spend the last 5 minutes adding a little bit of code so you get an idea how to work with these durable entities. The first thing that I'm going to do here is add a new class, and I will call this class traffic speed violation. Yeah, that looks good, and it's a regular class. Let's get rid of this whole file because I added it here, and it's pretty simple. Here is the speed violation lawsuit. Here you see it. It consists, let me add the exactly correct namespace here. Good. It exists of a bunch of properties. You can see it here. This instance of the C# class will be serialized into JSON, and it will be stored inside of Azure Storage as a JSON blob. What we can also add is some functions, convenience functions. Store the driver. Set the fine with some business logic, for instance. Here I'm simulating an async operation. Maybe we have to do some IO operation, ask the database for the correct fine value or whatever. And we can also have here some initialization code. In my case, when this durable entity is created initially, I'm initializing some properties, like for instance, setting the paid flag to false because it hasn't been paid yet. You can take a look at the details of this code. It's really, really simple. It's not that complicated. And we also, just for convenience purposes, offer a delete method here to delete the lawsuit from the database. Now, how can we now work with this stuff? We have to add here in our function file, we have to add a bunch of helper functions. I mean Azure functions. This one. These are regular Azure functions. Let me quickly add the new namespace here. Okay, these are regular Azure functions. You can see them here. And what they do is they get the durable entity key. This is the key that we get from durable entities. It can use, again, the durable client. You have already become familiar with the durable client. It can use the durable client SDK to get the persisted entity based on the ID. And then we can call, if we want, in this case, it's just a getter, but down here you can see it. We can call methods on it. And in this case, I am, let me move it here. I can, for instance, say, hey, dear entity, I would like to call the store driver method, and I have a driver name for you. And with that, in Azure Storage, we will store the driver name into the existing durable entity. We do not need to create our own SQL database. Everything is stored automatically in Azure Storage by Azure Functions. All we need to do is we need to provide this durable function class. It's this one, and we need to offer some methods that we can call from regular functions. Last but not least, let's add the code, and that is the last snippet that I will add here. And we will do it. Where is our speed violation recognition? Where is our orchestration function? Here is our orchestration function. No, this is our orchestration function. Here we will start the lawsuit. Create lawsuit entity. Here, once everything is okay and the user in Slack told us, yes, the license plate is correct, we are using the API of Azure Durable Entities to create a new durable entity. And then we just set the speed violation, the base data to this durable entity, and that's it. From then on, we don't need to deal with this entity anymore. Everything is done through the helper functions that you have seen a second ago. So let's do this final demo. Let's run this guy. Okay, we can remove the breakpoint here. I already demoed that. Good, it's running. So let's go here and start first a new process. This one is the process. Everything is fine. Now we should have a durable entity. How can we find out whether we have a durable entity? We can get the status of our durable function. And in my case, oh, sorry, I have to first process the Slack approval. Yes, everything is okay. Let me do it again. Sorry, I pressed it the wrong. Yes, everything is fine. Now let's get the status. And what I have here in the status is I have a custom status here, which can be filled with the ID of the durable function. This would be the lawsuit here. And then I can pass in the custom status here to get the status of the lawsuit, and I can use the custom status and pass in the name of a method that I would like to call on this durable function, and then I can pass in some data. This will, in Azure Functions, trigger my helper function, which we see here, set driver. This helper function will then use the entity ID to read it from the durable entity store and call the store driver method, you see it here, on our durable entity class, which is this one. And this store driver method does nothing else than storing the driver name here inside a property, and updating the whole thing in Azure Storage will be done automatically. So if I can take a look, if I scroll here to the right and I scroll down a little bit, then you will see that we see our, here it is. Where is it? Yeah, here it is. This is a typical JSON blob as stored by a durable function entity. So the serialization and deserialization and persisting of the data is done automatically without us having to write any code for that. So to quickly summarize what I wanted to show you with that, it is possible with Azure Function to not only write short-running functions which finish within a few milliseconds, but it is possible to run long-running functions here, and the whole storage area will be covered by the durable function runtime. That was my demo, and I can ask the nice producer if we have any questions that I have to answer.
Hi, Rainer. So there are no questions, but you are just 10 minutes before the next session. So if you can just wrap up within 5 minutes, that will be fine. But
okay.
Well, no questions. No questions Q&A.
Very good. No question in Q&A. That's fine. So again, I can recap what we did and describe again what you can do with this stuff. Regular functions, short running, durable functions, long running. Instead of you yourself having to create a database and create a record and store every change of your properties manually, you can just write plain C# code and add a little bit of Azure Function API calls there. And then the whole Azure Function runtime will make sure that everything is stored properly in Azure Storage. You do not have to care for maintaining the storage, for calling the serialization methods, for calling the deserialization methods. All these things are covered by the Azure Functions runtime. That's all.